Just give this a minute. So if you're online and you're here for the Zarr tutorial, I see about 100 people online. This tutorial is interactive, okay? So I'll keep putting the link in there. And what you should do right now, if you want to follow along with the tutorial, is to go to that repo and click on this link to launch binder. Okay, this is going to take you to a special binder and GeoBinder. You're going to have to log in with GitHub, your GitHub user ID. All this does is prevent crypto miners from abusing our binder by requiring a login. And this binder is going to give you just a little bit more RAM and a little bit more CPU than a typical binder. And we also know that it's running in the AWS US West 2 region, which is where our data are going to live. So yeah, go to this link. I keep dropping it in the chat here, and click on that launch binder link. And apologies in advance, I'm a little bit sick. I got a little bit of a cold, so if I lose my voice halfway through this thing, hopefully we'll be able to recover. So it's really hard to give an interactive tutorial without any feedback. And the way this GoToMeeting is set up is that we're presenters and we can't see the attendees. We can't see any comments from them. So there's no feedback from GoToMeeting about the tutorial. Okay, so I see someone is having. If you get an error, just try again. Okay. What I'd really love to get is some feedback over in the chat here of who. If you've tried to access this binder, give me a thumbs up if you're launching your binder right now.
And just a small note for everyone, I would be keeping an eye on the Gitter and the chat. So if there's any question meanwhile while the Ryan is delivering the tutorial, let me know. I'd be more than happy to, like he has told me to interrupt during the tutorial because he wants to be like interactive.
Yeah. So if you're having an error, please just close the binder and try the link again. Okay, that is the solution to this problem. I don't know what these errors about global limit has been reached mean. Maybe that's GitHub complaining that too many people are trying to sign in too short of a period, but please just try again. Yeah, it's going to take you a little while, a few minutes to start up. Yeah, it's normal that it says it takes long to start up. You're loading a big Docker image with a bunch of packages here. Great. So I'm getting some feedback that things are working. I assume it's going to be taking us about 3 to 5 minutes for everyone to get their environment up and running. Okay. And so when you load it up, you'll end up in a notebook that looks something like this. And I'm going to make this bigger here and perhaps even full screen this so we can. So this is, actually the problem here is I can't see the Gitter. So I want to keep an eye on the Gitter. Okay, so Sanket, I'm going to rely on you to pass through any questions that come up in Gitter and just say them out loud to me, because I want to full screen my notebook here, and that means I won't be able to watch Gitter. So does that sound like a good plan?
Yep, got it.
Okay, I'm going to wait a few more minutes and just give everyone a chance to get that binder up and running. This is telling me we have 140 attendees. That is a lot to do this interactive tutorial. So I only saw a few comments in the Gitter that people are actually planning to follow along, but that's great. This works better with a smaller number. So let's start talking about what we're going to do today and who this tutorial is for. Okay, this tutorial is aimed at intermediate Python programmers. Oh, I wrote programs. It's not actually aimed at programs. It's aimed at programmers. So it would be great and helpful if you're already a little bit familiar with Numpy and perhaps have also used Xarray. You'll get the most out of this tutorial. But even if you've used neither, you're welcome to follow along, and hopefully you're going to get something out of it. So this is going to be a live coding tutorial. Okay, I am going to type code in my into my notebook here, and I'm going to hope that you will follow along and type the same things. And that ensures I can't go too fast, okay? So this is not a talk, this is not an overview, this is an actual lesson where we're gonna teach you how to use Zarr. But that only works if you actually follow along with in a blank notebook and try to type in the code yourself. Okay, so some of our goals for today, we wanna really learn to identify the fundamental data structures in Zarr, groups and arrays, and the key properties of arrays, which are shape, dtype, chunks, and attributes. Then we're going to learn how to create those arrays and groups in both local files and directly on S3. We'll learn how to create and edit attributes and put data get data in and out of these arrays. We'll look at some of the trade-offs of different chunking strategies in arrays. And then we're going to learn how to use Zarr together with Xarray to write netcdf style data to S3, and then how we do parallel distributed processing. We're not actually going to do distributed processing in this tutorial, but we will look a little bit about how we use DAS together with Xarray and Zarr. So any questions about that agenda or any concerns that people are having before we jump into the live coding?
There seems to be an issue for fail to connect to event stream.
Yeah, just refresh your browser if you get that error. Okay, if you fail to connect to event stream, just click refresh. Okay.
And can you also increase the text size, like zoom in a bit?
Great. Yeah, happy to increase the text size. Okay. So you'd often just refreshing the page will fix the fail to connect to event stream. Okay, I'm gonna jump in and I'm gonna go pretty slow, and please interrupt me if there are problems. So
yeah, just before you start, everyone is getting a 503 error, service temporarily unavailable after they are refreshing. Is it because of too many requests at a single time?
I guess we crashed our binder.
Mm-hmm.
Okay, backup plan. We are going to switch to, okay, the binder's back. I don't know, maybe we have overwhelmed it with 100 people trying to access it at the same time. So for me, it's back up and running. Okay.
So yeah, for some people it's working, for some it's not. So
okay. Yeah. The alternative is to just go to regular binder. And so the way we would go to regular binder is take this link, plug it in here, and just put mybinder.org. And that's going to take a while to build, but it will work. So if you are truly unable to get, okay, you can also try this with mybinder.org if the Pangeo binder is really failing to comply. If you fail to connect to an event stream, just hit refresh on the page, okay? let's talk about why we're doing this and why we're feeling this pain. So the reason we're doing this is because we're going to actually read and write to cloud object storage. Okay. So that requires that really works best if we're running in the same cloud region as where our data are living. So that's the reason why we are trying to use this specialized Pangeo binder. You can, of course, run the repo locally. However, okay, so we're having a real problems with this binder. So this is going to be it's going to be an issue. The reason we're trying to do this is so that we can quickly get the environment with all the packages we need up and running, and then have access to that cloud data. So we're just gonna keep waiting here and keep trying. Let's see. So I'm getting, there's plenty of sort of errors being reported here in the Gitter, but is anyone actually in? If you're hearing me and you're actually in and you're staring at a blank notebook, can you just give us a little feedback in the Gitter and say, you know, thumbs up, like I'm in, just so we can gauge whether this is just a few people who are having problems or if everyone's having problems. Okay, Eve says he's in. Error. Okay. So someone says my binder is working. Stephen is not in. Okay, so we're having big problems with this binder. So far, Phil is in, Hadi is in. Okay, so people are in with regular binder. Okay, so looks like we're had some issues with the Pangeo binder, but with regular binder, we might be doing better. So looks like we've hit some of the scaling limits. Okay, well, this has been a learning experience for me, and I'm really sorry for the friction that people are feeling here. This is kind of what it means to run open source infrastructure in a community-driven project. Go ahead and clone the repo, but there's no environment specification in it because that was planned to be accomplished with binder. So chances are you will not have the dependencies installed and you won't be able to run the examples that way. It looks like my binder is probably our best choice, and those seem to be working relatively well for people. So
yeah, I think we should start now, and you know, people could just follow along through the webinar.
Okay, great. Well, let's jump in then, because yeah, we've spent almost a quarter of our time on this, and so let's just dive into it. Okay, so in order to understand how to use Zarr, we first need to remember a few things about Numpy. So let's import Numpy and remind ourselves of how we create an array in Numpy. Okay, so I'm going to create an array, call it A, full of zeros. Now, when I create an array in Numpy, I have to specify a shape and a D type. So I'm going to use F8, 8-bit floating point number. So and those properties, shape, are attached to my array as attributes. Okay, so those concepts of shape and data type are really essential for understanding Zarr and Zarr arrays. So we've created an array with shape 10 by 20 with float 64 F8 type data in it. And it's useful to think about how much memory does such an array use, n bytes. Okay, this tells me the number of bytes in this data in my array, and that number is just 10 times 20 times 8 bytes per item. That's 1600. So, you know, this NumPy array lives in our computer's RAM. So obviously we cannot create arrays any larger than the array, than how much RAM our computer has. And these binder environments really just have a couple gigs of memory. Zarr will let us create an arbitrarily large array using the same semantics of shape and dtype. We could create an exabyte size array. Okay, let's also remind ourselves of how we get data out of a NumPy array. So we can use, for example, slicing. If I want to get a little piece of that array down in the corner, 2 by 2 slice of that array, I can use that slice notation, and it gives me back another array that is that matches that slice. We can also assign to arrays using the same syntax. So if I create a new array, np1s, I'll make this one bigger, shape equals 40, 50, and dtype equals F8. I can assign to that array from another array. Okay, so now if I look at one corner of this array where I assigned A to it, 0, 0, that's going to be 0. But if I look at the other corner of the array, that's going to be 1. Okay, so just some basic, simple NumPy review, but these concepts of slicing arrays, creating arrays, specifying shape and dtype are going to be important when we get into Zarr. So I'll pause for 10 seconds and let everyone catch up. Make sure you're thinking in terms of NumPy arrays, shape and dtype. Now, forgot one important element here. Okay, so when it comes to Zarr, a Zarr array has not 3 but 4 important properties. 2 of them are shared by NumPy arrays, so shape and dtype. But other attributes of Zarr arrays are this concept of chunks and attributes. And so we'll go to learn what those are. There's an additional property that is filters and compressors, but I've decided we're going to skip that in this tutorial. Okay, so to understand how to create a Zarr array, we're going to import Zarr, and we're going to create an array like this, Zarr.create. And just like with NumPy, we're going to say shape equals 40, 50. So it's going to create a 2-dimensional array. Chunks equals 10, 10. Oh, sorry, let's start with dtype first. Dtype equals F8. And there's this additional parameter that I'm going to give to it, additional argument called chunks. Okay, and chunks is really what sets Zarr arrays apart from NumPy arrays in terms of the API. We are taking this big array and splitting it into smaller chunks. Okay, so now I've got this Zarr array here. It looks kind of similar to, the repr looks kind of similar to NumPy. To learn more about this array, we're going to look at this attribute called info. Okay, so this is a great way, info, to introspect Zarr arrays. So we can see here what is our type of our array. This is a Zarr core array. We have our data type float64. We've got both the shape and this chunk parameter. These things aren't that important, order, read only. But here we can see some interesting attributes, which is the chunks initialized. So we've created this array here, but we have not actually initialized any of the storage in it. So I forgot, I'm reading this tutorial off of my phone in order to be able to give this live tutorial, and I forgot a very important argument when creating this array. So but this actually illustrates an important lesson. So right now, this array lives in memory, just like a NumPy array would. If we want to make an array that is stored on disk somewhere, okay, we need to specify an actual store argument that tells Zarr where to write the data. So I'm going to add this keyword argument store, and I'm going to say test.zarr. Okay, and I'm gonna rerun these cells. Oh, you're not gonna get this error. I ran this earlier this morning, so I'm just gonna remove my old array, star and rerun this cell. All right, okay, so just rerun that and this will work fine. And so now we've created the same array, except it's now living on disk. And we can see that information down here. It says store type down here, Zarr storage directory store. Okay, so no data has been written to this array yet. Okay, and so if we try to get any data out of it, say if I try to index it, I'm just going to get 0. And that's because this array has this attribute called fill value, that if data in our array is not initialized yet, it will just return this fill value.
So Eves is asking a question, not a question, but he's saying that I get zarr.storage.kv store instead of directory store.
Yeah, you probably forgot the store argument here. If you're getting that error, that if you're getting that you have a memory store or something like that, you probably forgot the store argument. Okay, well, I guess a good question, and we'll address this next. Hopefully it's creating the data on disk. Maybe this is just a slight version mismatch between my environment and yours. Let me try that actually over in the binder, because I think I just launched that binder. So let me just see info. Yeah, so this is running in that binder. I do get the directory store. That's interesting. I don't know why you wouldn't be getting a directory store, but we're just going to move on. Okay, so if you specify the store argument, it will store your array on disk. Okay, so let's move on. So far we haven't written any data to our array, but we're going to do that right now using assignment here. I'm going to write data to my array using this as sort of assignment syntax. I'm going to just use this z, open brackets, colon, close brackets, equals 1. So I'm just going to write 1 throughout the array. And now I'm going to look at z info again. Now you can see this info is telling me I have 20 out of 20 of my chunks initialized. It's also telling me some interesting information. There's 16,000 bytes in this array, just like the same example we were using in Numpy. However, there's only 1,277 bytes stored. That's because the data were compressed, and because we're providing just all the same value, the storage ratio is very large, a factor of 12 or more to store all this data. And I think by tweaking the compressors or using different data types or filters, we could get that storage ratio much, much higher, because this array just has 1s in it. But anyway, it's rare that we would just have an array full of all of 1s. Okay, so we're going to delve more into these chunks and things first, but I real quickly want to just talk about this other property of Zarr arrays that distinguishes them from Numpy arrays, which are the attributes. Okay, so we can put arbitrary metadata attached to these arrays, just using as like basically a Python dictionary. Units. I'm just going to assign some units to this array. And if I just look at that, let's do it like this, right? I can see that attached to that array, I now have this dictionary of attributes that I can keep together with my data. And that's very useful for scientific and geospatial data. Okay, so let's look under the hood of this array a little bit. Okay, now I want to make a point here. This is what we're about to do is really one of the key properties of the Zarr format, that it's pretty easy to just look inside, peel back the covers. And that's not the case for most other binary data storage formats, right? So like for a cog, you can't just using the command line sort of peek inside what's inside a cog. Same for HDF file. The ability to look in a Zarr store and understand what's inside is a deliberate design decision by the Zarr project to make the format very simple and transparent of how the data are being stored. So in this case, the store underlying our array is what's called a directory store. That means the data are stored in a directory hierarchy. And I'm just going to use the tree command, test.zarr. I'm just running the shell command to look in this directory. So this Zarr file I created, test.zarr, is not actually a file. It is a directory. And here we're looking at what lives inside that directory. Okay, and what we can see here are two metadata objects, this Xarray and Z attributes, and then a bunch of these 0.0, 0.1. These are the actual chunks of data. That is how the Zarr array is stored on disk. And there's 20 of those. So I want to show you what this metadata actually looks like. So Xarray and Z adders are actually just JSON files. So we can just open them with JSON and look at what they are, what's contained in those. So I'll import JSON and I'll open test.zarr.zarray as FP, and then I'll display JSON load FP. Okay, so this is that Xarray file, JSON file, displayed as a Python dictionary. And this really contains everything, all of the sort of internal details that Zarr needs to know in order to materialize that data into memory. It tells us what the chunks are like, what the data type is, what the shape is, and what compression has been used to store the chunks. And that tiny JSON file is all that's needed to reconstruct the overall array. We also have the metadata, so I'm just going to replace this, copy and paste this with Z adders, and look at that, and we can see our metadata has just been stored into a JSON file with that units, meters per second that we specified. So this is, if you're saying, whoa, this is like trivially simple, you're right. That is the point. This is kind of like the simplest possible way you could store chunked, compressed array data with metadata. It's so sort of simple and logical in a way that like multiple different projects have actually landed on this way of storing data independently and then merged and aligned as part of the Zarr project. So the best example of that is the N5 project that began in the bioimaging community. N5 sort of designed their own chunked, compressed on-disk array storage format, and it was so similar to Zarr in its design and its simplicity that these formats are actually interoperable. And you might also be noting some parallels to COG, right? We know from the talks yesterday that COG is a internally inside a COG, there are various chunks of data, the tiles, and there's metadata. And so, there's definitely, some similarities there. Okay, so I want to do one more thing, and then we'll stop to take some, do some discussion and take some questions. So this property of this element of chunks is pretty important. Okay, and this is sort of the main variable and also point of confusion that people have when they start using Zarr. The main parameter, generally we don't control the shape of our data or the data type. Those are things that are determined by the the data we want to analyze, the sensor that measured it or the model simulation that was run. But we do control the chunks. Okay, and chunks have a strong impact on the performance of Zarr. So there's two kind of rules of thumb to keep in mind when choosing chunks for a Zarr array. One is that writes can be concurrent. That is, they can come from different processes simultaneously if they do not touch the same chunks, right? Because these chunks, in this case, are just separate files. So many different processes can write them at once. So this enables massively parallel writing of data in the cloud, which can be really useful for some applications. On the flip side, when reading back data, if any piece of a chunk is needed, the entire chunk has to be loaded. Now, this constraint might be relaxed in Zarr v3, but as far as I understand, it's the same for cog. If you need to get a piece of a cog, basically you read only the tiles that are needed to be read for that data slice, but there's no partial reads within those chunks. Okay, so to understand this, here we're going to compare two different chunking strategies. Okay, so I'm going to create two arrays. Zarr create. I'm going to make these a bit bigger. I'm going to make arrays that are 200 by 200 by 200. And for the first array, I'm going to specify chunks equals 1, 200, 200. And we'll make the D type equals F8, and we'll put the store equals, we'll call this c.zarr. Okay, so that's one chunking strategy. And I'm going to assign some this time I'm going to assign random data to it in order to not have a lot of compression available to us, which could affect the results here. So what I'm doing in these two lines of code is I am creating the Zarr array with a certain chunk structure, and I am assigning random data to it. So now all the chunks are initialized. So what this chunk argument means is that the data are contiguous along this second and third axes, but along the first axis, they're chunked. So now what I'm going to do is I'm going to time a pattern of reading back data. Here's how I read data out of that array. I'm going to just get a single, you might think of this as a time series. If you're thinking of this as your time dimension, I'm going to get a single time series or just one-dimensional array at the 0.00 out of that. I'm going to run that cell. That took 504 milliseconds. Just bear with me here. Now I'm going to do the same thing with a different chunking structure. Zarr create shape equals 200. So same shape. However, I'm going to use a different chunking strategy. I'm going to say 200, 201. Same D type, F8, and I'll call this store d.zarr. I'm going to do the same thing, assign to it in the same way. D equals np random rand n d.shape. Okay, so I've written this, I've initialized all these chunks, the data are stored on disk, and now I'm going to read back this data using the same exact access pattern. That is definitely not what I was getting in my initial, oh, that's because I did C, D, okay, there, good. So it was over 100 times faster in this second array, D, okay? And so this is a really good place to stop and discuss a little bit. What we've just seen here is a really important property of Zarr arrays, which is that we can choose the chunk structure however we want, and that chunk structure is going to really affect performance. So let me explain exactly what happened here. In this example, we created this array C that was contiguous along the last two axes and chunked along the first axis. And then we tried to read a piece of data that spanned all elements of that first axis. And that was pretty slow, 504 milliseconds. That's because it basically had to read the entire array just to get that one piece. However, here we created another array, same exact shape, same D type, but with a different chunking structure that was contiguous along that first array. And so when I went and tried to read that data, it went over 100 times faster. That's because it only needed to access one single file in order to get that data. Okay, so this is a huge power and flexibility and freedom that you have as a developer to choose the chunks that are optimized for your problem. There is no such thing as a universally perfect chunk size and shape. It's all about trade-offs, and some things that you need to consider when you're choosing these chunks are the access patterns for your data. How are the data going to be queried? The latency and throughput of the storage device that you're using, and constraints on the number of files. So obviously you could put every item in its own individual chunk, have chunks of 1, 1, 1, but then you would be creating a huge number of files. So these things all have to be balanced by considering what is the storage device where the data are being stored. And I think that's a good place to take a little pause and take any questions or get any feedback from the group. I'm going to switch over to the Gitter and see what people are asking for. So yeah, so someone asked how to change chunks on the fly, and it's actually not that easy to change chunks once you have created a Zarr array. If the data can fit all in memory, you can just copy the contents of one array to another. So for example, I could say, you know, C equals D, right? Assign the data from one array to another. That's not going to be particularly fast at all because it contains some, and basically I'm just loading all of the data into memory. So that's not a solution for big data. For big data, we actually developed a solution for this that's called this rechunker package. So rechunker is really designed to address this question of how do you transform the chunks of two arrays from one to another, and I'll put that link in the chat here. It is in general kind of a hard computational problem, and it's pretty nasty. And so we developed an algorithm, and that algorithm can be deployed using Dask or Prefect. Apache Beam was a couple of different executors for it, but it's not actually a trivial problem. So any more questions about the sort of the basic data structures? So someone asked, what's the difference between Zarr arrays and Xarray? So Zarr is a data storage format. Xarray is an API and a data model for computing. So I'll make an analogy. Zarr can be thought of analogous to a file format like CSV or Parquet, and Xarray is a data analysis library like Pandas. Okay, so Pandas is not a file format. Xarray is not a file format. It's a computational library that you can use to do data analysis. So Zarr is comparable to other generic array storage libraries like HDF5 or TileDB. They occupy the same space. Zarr doesn't really have much processing associated with it. All the Python Zarr API really does is get you your data in and out of Zarr storage, and then you pass it along. Once you materialize it, you can materialize it into Numpy or Xarray to do your computing. Okay, let's move on. One cool thing about Zarr is that it's really easy to resize arrays, right? So if I want to make my array bigger, I can just do it like this, right? So now I just increase this array. All I really did here was edit the metadata, and now you can see only half of those chunks are initialized. But that's really pretty convenient to be able to resize your arrays like that. If you make the array smaller, you'll discard data, of course, but that's your choice as a developer. Okay, so moving on a little bit. Now I mentioned compressors, but I'm not going to go into, I've decided for the sake of time, I'm not going to go into detail on compressors. Compressors are a very interesting and deep topic. Let's just say that Zarr has extensive support. Basically, every different compression algorithm that is publicly, available and widely sort of supported and is supported in Zarr. These compressors live in a separate package called numcodex. We use BLOSK very heavily. That's the default compressor. And it's very easy to implement your own compressor if you have a new compression algorithm. And so we're seeing, we constantly see new compressors being added to numcodex. So, but I'm not going to go into detail there. Yes, Sanket, what's up?
Yeah, there's a question on Gitter by John.
Yeah, John's asking about CF compliant metadata in Zarr mirroring netcdf. We're going to see that right now. And so that's a great question, John. And if you just can be patient for 2 minutes, we're going to get there. Okay, so for the sake of time, because we started late, I'm going to skip the section on groups. Groups are pretty straightforward. If we have many arrays we want to keep together, we can organize them into a group. And I'm going to skip the live coding on that so we can move a little bit faster. Okay, so now here we come to the fun part. We're going to write some data to the cloud using Zarr. I've actually created a bucket for us, and I've given you all the credentials. I'm going to disable these credentials as soon as our tutorial is over, but I thought it would be more of a fun tutorial if we can actually write some data to S3. So you now all have read-write access to this bucket. And what we're doing here is creating a unique path for everyone to work in. And so I'm going to show you, I'm just going to start typing a bunch of code about how we're going to create some data in S3. So I'm going to first define a target path using a format string here. So we'll put this in my folder, and we'll call this test.zarr. This will go in S3. And to create this store, I'm going to use the following syntax. There might be something more concise, but this is the way that I find easiest. Zarr.storage.fsstore. So here we're using fsspec, the package under the hood, to create this store. And I'm going to pass as extra keyword arguments these storage quarks that contain my credentials. Okay, so now I'll get to that part on groups. We're going to create a group the following way, Zarr.group, and I'll specify the store is this store. And then within that group, we're going to create some arrays. Group create, name equals foo, shape equals 200, 200, and chunks, I don't know what chunks I used. I can't read it in my original example, so I'll make them pretty big, 50, 50. Then I'll put dtype equals F8, and then I'll create another array, group create, name equals bar, shape equals 100, 100, chunks equals 120, and let's make it like this, 20, 20, and we'll do dtype equals I4. You can create whatever you want. So now we've actually created this on S3. Takes a little bit longer for it to initialize these arrays. Shouldn't take too long here. Are my credentials working here? Okay, so wish it didn't take that long, but we initialized this array. So there, we're good to go. Now what I'm gonna do is assign some data to foo. Group.foo equals np random rand n, and I'll just give it the shape of foo here to, so there we go. I have now written data to S3. It's living in S3. And if I do info here, yeah, I can see some similar information. I can see that all of these chunks are initialized. There is not much compression at all that I could achieve on this random floating point data, but this data has been persisted into S3. And we could read it back and do all that stuff. I'm going to skip the next section I have about consolidated metadata because we're really running out of time, and I want to get to the question about Xarray and John's question. So let's just move on into Xarray and just drive forward. By the way, all the code that for this tutorial also lives in that GitHub repo. So I've sent you to a blank version of this notebook, but in the same repo, there's a filled-in version of the notebook. In fact, you can see it right over here. If you just want to open that up and see all the code for yourself, don't worry about having to like take all these notes or anything. It's all in there. So let's dive into Xarray. Import Xarray as XR. As XR, import hvplot.xarray. And to get a data set going, I'm going to open the tutorial data set for Xarray. We'll call this is called air temperature. And I'll just run all that. So what I'm actually downloading a data set from the internet right now to load this tutorial. So I have to confess that I almost never use Zarr directly. I almost never import Zarr in my day-to-day science work. Instead, I'm always using Zarr through Xarray because I love Xarray. I love Xarray's data model. So this is an Xarray data set. If you've used NetCDF before, it looks very familiar to you. We can see our dimensions, our coordinates, lat, lon, and time, and our data variable, air, with dimensions time, lat, and lon. Okay, so we can see there's metadata attached to all of these. This HTML wrapper is one of the reasons we love Xarray. And so let's take this data set and just write it to Zarr, okay? And write it to Zarr in the cloud. And I think that's going to answer a lot of questions. So first, what I'm going to do is chunk it, because it's nice if we chunk our Xarray data set, we will automatically use those chunks when we're serializing it to Zarr. So I'll just remind you, this data set has 2,920 time points, and I'm here saying that I want to chunk it in time with 100 points in time kept together, and the other dimensions contiguous. ds chunked. Okay, and so having done that, we can see now that this data is represented as a Dask array. The total array is 14 megs, and the chunks are about 500 kilobytes each. Though that's actually really small chunks. We don't really need to be doing chunking for this type of data set. It's a small data set. I'm just doing this to illustrate the capabilities here. In reality, you would if you're working with Zarr in the cloud, you're probably working with much bigger data sets. All of this scales up. So this is just demonstrative here. It's not meant to be like, we don't really need chunks or Dask or Zarr for data this small. But anyway, so now let's do the fun part. Let's define a path where we're going to write this data to. So path equals, put this in S3, my folder /airtemp.zarr. And now I'm going to do one more thing. I want a progress bar for writing this. So I'm going to, from Dask diagnostics, import progress bar. Okay, so and then what I'm going to do to write this to Zarr is I'm going to do with progress bar ds chunked to Zarr path, and I need to specify these storage options, storage quarks, right? So it's a little bit inconsistent naming here, but now I'm going to run that. It takes a little bit of time to set up the array, and then it's going to start writing all of those chunks to S3 in parallel. S3 seems to be running a little slow this morning, but there we go. So we just wrote that whole Xarray data set to S3. And now when we read it back, ds from S3 equals xr open dataset. Here's how we open it back. I know this is going fast, but I'm leaving this on my screen. So path engine equals Zarr, and then storage options equals storage quarks. ds from S3. and I guess I should put this down like this. So now I read the data back from S3, and I got a Zarr data set that looks like a NetCDF data set. Actually, I think this data originated as a GRIB data set, but anyway, coming straight from S3. And to me, that's pretty magical, and it's super convenient. Now, John asked, well, how is this being stored? How is this, you know, where is this coming from? Well, we can go under the hood again and open this data directly with Zarr. I guess I'll just stop there and let people catch up, because I've gone kind of fast and I typed a lot of stuff. So I'll just leave this on the screen. And
yeah, and there's also a
any
question.
questions, Sanket?
Yeah,
go ahead.
There's a question by Rachel, which goes like, if you open a Zarr with Xarray and then specify chunks that don't line up with what is in the source Zarr store, that doesn't actually change anything in the original Zarr store, correct? So you really shouldn't ever specify chunks if you're reading a Zarr store. Yeah,
so this is, I'm glad Rachel asked that question, because there's a couple different options that we can use when we're reading data back. As you can see here, by default, I didn't actually apply any chunking to this data set at the Xarray level. So we're not, by default, using Dask. If I specify chunks equals empty dictionary and run this again, you'll see what happens there is that by default, the chunks, the Xarray chunks, and the Dask chunks get mapped to the Zarr chunks. So here we have the exact chunks that we specified when we wrote the array. So that's chunks equals empty brackets. Another option is chunks equals auto. In this case, I think Dask will choose chunks for us, and in this case, it decides to just choose one big chunk for all of this data, because actually it's not very big data at all. I think the heuristic is to look for 100 megabyte chunks. So if you want to make sure that your Dask chunks, when you open the data, line up with the Zarr chunks, you want to specify chunks equals empty brackets. And I'll be honest, I don't love that API there. I wish it was a little less sort of secret spell that you had to specify here, but it is well documented. If I do open data set and I look at the document on chunks, if chunks is provided, it is used to load the new data set into Dask arrays. If chunks is -1, loads a data set with Dask using a single chunk for all arrays. Chunks equals open and close curly brackets loads the data set with Dask using engine preferred chunks if exposed by the backend. Okay, so, and I believe the same behavior actually will work for HDF5 files as well. Any file format that has chunks underlying it, Xarray will do this mapping.
Yep. There's another question by James. Can Zarr store unstructured grids?
Zarr can. People always ask that, and I would say the following. There are a lot of different ways to serialize an unstructured grid into into an array. So I believe Zarr can store unstructured grids. The reason I think that is because most unstructured grids, if they're coming from a model, they're written to a NetCDF file. And Zarr can store any data that can be stored in the NetCDF data model. So therefore, Zarr can store unstructured grids. Now, does Zarr have any understanding of what an unstructured grid is? No. At the end of the day, Zarr is just storing arrays of rectangular arrays of uniform data. And it is up to the higher level tools in our stack to understand the connectivity between the grid cells, et cetera, et cetera. So that's my answer there. There's a new project called Project Rygen, here. out of NCAR that is designed to create some computational tools around unstructured grids. And all of these grids, all of this data are ultimately stored in netCDF data, and these are the goal of this is to build some tools on top of Xarray that make it easier to work with those sort of unstructured grids. So I would say Zarr is pretty agnostic about what is the underlying structure of the data. It's just a way to persist arrays. Yeah, and I think we'll stop there. There's a bunch more examples, you know, that you can go through. Like at the end of the notebook, if you want to go through it on yourself, this is like the completed notebook here. You know, you're gonna see. Oh, we didn't do any plotting, but that's a lot of fun. You know, you're gonna see some examples of loading data like from the CMIP6 cloud data. Right, so if you want to run through those examples on your own, loading some data from climate models stored in the cloud. We didn't get to make any nice plots. The Muir SST data set is this absolutely massive data set. Each array is 15 terabytes, and that's what the chunks look like. So that is a very intimidating but very cool data set. So if you want to run through those examples, on your own time, you should definitely do so. We've ran out of time here, so sorry about the binder difficulties here, but hopefully you got something out of this, and we do have a few minutes for questions and discussion, so I'd love to just open it up here.
Yep. We have a question from James, which is it possible, planned, or appropriate to size chunks based on spatial footprint schema?
Is it possible, plan appropriate to size chunks based on spatial footprint schema? So I don't understand some of the vocabulary being used here, and it's not, but in general, you can choose the chunks based on your application. If you have an idea of what chunks would be well suited to your query pattern, then you can choose them in Zarr. Let's look at some of these others. So Rachel, Zarr, so unstructured grid. The utilities to convert netCDF and HDF files to Zarr without losing anything. Yes, Xarray. We just did it, Pavel. Xarray is that universal Swiss Army knife of data formats. Xarray can read GRIB, netCDF, HDF5, all of that stuff, and then serialize it to Zarr without losing any of the metadata. Zarr itself also has some tools to do this. When I'm working with data, I almost always go through Xarray, but Zarr itself has tools to do that. So Val asked, any reason you're using XR open dataset engine equals Zarr compared to OpenZarr for reading data back from S3? Basically, OpenZarr is being deprecated, and we want to have all reading go through open dataset. So are there plans to implement data versioning and deduplication within Zarr? There's not currently plans for that. I maybe Josh could say more about that, but I don't think that's on our roadmap right now. Leaf Denby asks if he should make his large eddy simulation write directly to Zarr. Yes, you should. There was a really interesting study from NCAR evaluating the performance of Zarr as a HPC data format. I'm going to try and dig up that study after I close here, but it works great on HPC file systems. The main downside really is that it does create a lot of files, and some file systems, HPC file systems, don't like that. As for calling it from Fortran, well, you can, the netCDF library actually now supports it. So maybe you can just even go through netCDF. Okay, Zarr plan to be supported by Stack. Yes, we're working on it. We've had a little bit of difficulty fitting Stack into the Zarr into the Stack data model, just because Stack is itself, Zarr, you can almost think of Zarr as a catalog, right? It's a catalog of chunks. It has its own approach to metadata. And so there's a lot of overlap in terms of concepts you know, between Zarr and Stack. But yes, we need to make them talk to each other. we're getting some other questions, but I'll try and answer some of them in the chat. I think we need to move on now because we're at the end of the hour. So thank you all for engaging with that. Sorry for the friction around Binder. Hopefully everyone who wanted to was able to access the material, but in any case, it's all on GitHub if you want to follow up in your own time. So I'll stop there.